Jordan Guerrero, Monica, Monica Hickson.
Here, here.
Do you have any strong thoughts one way or another?
Say it again.
Do you have any thoughts about all that?
What happened? I don't. I just clicked in.
I sent you an email.
Oh, okay. I'm sorry. I just came from a birthday dinner. I will definitely look at it. I'm sorry.
Okay. How about Lillian? Are you there? Holmes? No,
Yes, I'm
Lillian?
here.
Okay.
What?
Reba?
I'm here.
Emma? Emma Levert?
Yes, I'm here.
What are your thoughts, Emma?
I don't mind either way.
Wow. I got you, Sharon. What about Rosio? Are you there? Rosio Morales? Not here? Indira?
I'm here.
Gabriel Mulvaney?
Here.
Amanda?
Yes, I'm here, and I strongly favor not having class on Wednesday because I will be traveling to West Texas.
That's good to hear. Edith Narrero? Edith, are you out there? So you're Edith, right? Edith, do you have any comments you'd like to make or not? Nothing from Edith. Edith, you've dropped off our thing again. We don't see you there. Disappeared. How about Dylan? How about you? Oh, Vincencio. How about Joshua Trehu? Holly. Erica Whitehead.
I'm here and I'm in favor of no class on Wednesday, please.
All right. Well, I take and roll. I can go over it again at the end. Let's proceed. I send out the official memo about tonight's class. I've done the review for this, and it's about 2 normal classes, a little bit less, depending on if you are paying attention, I guess. So I'm already at the book, and we're supposed to be doing, I believe, 8.3 and 8.5. Let's go to 8.3. These are geometric sequences. Can you all see it?
Yes.
Yes.
Yes, sir.
Okay, so let's go through it. A geometric sequence is given by a ratio of the second term divided by the first. So you can see in this sequence here, the ratio is 5. I'm getting some feedback. Sharon, it's on you. Thank you. All right, back to the book. So they say in example 1, they want you to write the first geometric sequence, 6 terms. When you start out with 6, multiply by 1/3, you get 2, multiply by 1/3, and so on. Because the geometric sequence is based on multiplying by a number or factor. That's pretty easy, number 1. Every term is multiplied by 1/3 to get the next term. Now, a general term of a geometric sequence is found by using this formula. A, the 1 stands for the first term, R stands for the ratio, N stands for the term minus 1. So let's look at this one. It says find the 8th term. First term is -4, and the R is -2. Well, if you look at the equation, second line under solution, you can see they get 5, 1, 12. Again, how do they get it? The first term, A, the 1 is -4. R is the ratio of -2 because it's given. Excuse me. And then the N is the 8th term. 8 minus 1 is 7. Does anyone have a question about this one? Excuse me. I have to blow my nose there. So I'm assuming that nobody's saying anybody's got it. Well, this is a geometric population growth. What is the ratio? Can anybody calculate the ratio for me here? Based on what we talked about, what is the ratio? Somebody? Does anybody know how to calculate it? Does anybody want to know how to calculate it?
Yes.
So to calculate it, you just take the second term and divide it by the one in front of it. Or the third and divide it by the second. You're going to get the same thing every time. So if you take 84 and divide it by 281.4, you're going to get 1.00923591. So the ratio is 1.009. Now, if this is a geometric sequence, if you took 286.6 and divided by 284, you're going to get the same thing. If you take 289.3 and divided by 286.6, you're going to get the same thing. And there you see it. It's extremely easy. Can I get an amen out of that? All right. I guess there's not a lot of church goers out.
I think I'm understanding now. I see what you're doing.
Thank you. You guys are kind of scaring me out there.
I'll give you an amen.
So in order for it to be a sequence and a geometric sequence, the ratio has to be the same. And it is for every one of these. Next one. Now, in a Ponzi scheme, people say, oh man, those are bad. Well, if you look at them, it depends on when you get in on them, and it depends on when they're going to end. So the guys in A1 round one are going to make money. They're going to double their money. But somewhere down the line, everybody's going to lose everything. So look, in round A1, this guy collects $100 from each person. In the second round, he collects $100 from each person, pays the first guy's back, and keeps half the money for himself. But the first people are happy because they say, well, I already made my money back. Round 3, the first round gets, so they doubled the money. Round 2 gets the money back. So he's getting good responses by 1 and 2. And then round 3, and folks are going to be happy if round 4 pays up. But sooner or later, it collapses. Now, the sum of the first n terms of a geometric sequence, I want to know what they add up to be. So I want to know an example 4 what these add up to be. 2, -8. So what's the ratio? It's -8/2, so the R is -4. 32 divided by -8 is -4, and so on. The first term is 2. So we're going to plug in all the numbers. There's your ratio, -4. Again, you take the second number, divide it by the first number, or any number divided by the number in front of it. So we know the R is -4. The first term is 2. And we're just going to put it in, see. So if you look at the second last line, you have 2, 1 minus a -4 to the 18th over 1 minus -4, which is 5. Now, notice that this is put in your calculator and should be pretty straightforward, but it is not. I'm going to put it in just so you can see how I've done it. I'm going to go to my calculator. I don't know if it's lit up anymore. Probably not. Sleep. Push it over on top of this. There we go. And oh, come on. I have to go back to it. There we go. Boom. So can you all see my calculator?
Yes.
So I take 2, open parentheses, 1 minus, open parentheses, negative, that's this number here, 4, close parentheses to the 18th power, push out, close parentheses again, and divide this all by 5. Let's see if we get 2.74, and of course to the -10, which is exactly the number that the book has. You might practice putting them in your calculators. All right. Now, summation notation. In order to do number 5, you really need a calculator that is modern, that has summation notation. You can see with the summation notation is sigma. Let me write this up for you and express it 2 ways. Let me go to my whiteboard so you can see this. So for your calculator, we're looking for sigma. That's this thing here. Now the book gives you I. It says equal to 1. Now we can use X for I. It's easier, but we can also use I. And it wants us to go from 1 to 10. No big deal. And then it says it wants to take 6 times 2 to the I power, and it wants us to add them all up. This is called the expression. And the range is from 1 to 10. So we're going to plug in where it's I, 1, 2 to the first power is 2. 2 times 6 is 12. Then we're going to put 2 in there, and that's going to give us 4 times 6 is 24. And we're going to go all the way up to 10, and this little calculation is going to add them up for us. So are there any questions of how to read this?
No, I think it's straight to the point, honestly.
Good deal. Thank you for saying that. Makes me feel like someone's listening. I think there are. Some of these people are just shy. So here we're going to calculator. I'm going to get rid of this problem. Summation notation. Let's go to math. Let's see if it's down here. And there it is, number 0. Now, if you don't have this on your calculator, you need to get one that has it. That would be my best advice. So we're going to enter. Now, we said we're going to use X where A is, so hit X. We're going to put in 1 here. We go to the top. We said we're going to use 10. I think. Did we say 10 or 6? Does anyone remember?
10, yes.
Yes, we did. And then we said 6 times 2 to the I. So, but we're going to use X. I'm going to push it out and get out of there. And now we have it. 1 through 10, 6 times 2, we hit enter. We get 12,276. And that's right. $12,276. Boom. Is everybody okay with that?
Yes.
Mine
Well,
said
then.
syntax. Mine said error.
Did you put everything in right?
Yeah.
Probably. Let's go back. I don't think so. Because you only get an error if you. So you have with your calculator one that looks just like ours in the window here, right?
Mm-hmm.
Okay, you put 1 here.
Oh, never mind. I got it.
All right. All right. Good deal. I mean, usually these things are just a little bit of mechanical stuff. Believe me, I did this prior to the class, and I thought my calculator was broken twice. Kind of. Now, this is interesting. How much money do you think a guy that makes $35,000 a year with a 5% increase, just over 30 years, how much do you think this person makes $1 million? Anybody?
No.
In fact, he makes $2 million at 35,000, which is not a great salary, but with a 5% increase every year for 30 years. Using the formula that you have here, A to the 1, first year is 35,000. 1 minus the R is 1.05. N stands for 30 years. And 1 minus 1.05 is a negative 0.05. You put all this in your calculator, just as shown. He makes approximately $2,325,360. Now, 8 to the 1, I'm not going to put it in the calculator this time, but you should note 8 to the 1 is the first amount of salary, first year, 35,000. 1, this is the formula given to you right in blue, minus the ratio. The ratio is 35,000 times 1. It's 1.05 because that's what every salary is multiplied by. So that's the same ratio for everyone. So it's 1.05, n is the number of years, 30. And then 1 minus r, which is, again, the ratio 1.05, will be a negative 0.05. Can anybody give me an amen that you get this number, or do you want me to work it? Anybody want me to work it?
That's what I got.
Okay. It's just a matter of putting in your calculator. And then I would just remember, instead of dividing by 1 minus 1.05, you have to put parentheses. Or you could put negative 0.05. Now, this next problem, I have taught you to use the Finance app. So let's go down this with the Finance app. At age 25, this person decides to retire. They're going to put $200 in every month in an IRA. It pays 7.5%. They're going to make this until they're age 65. They want to know how much money they make. Well, let's put it in our calculator. Now, I think I've done this in advance. Oh, it's wiped out. Well, so we said every month for 25 years. Well, let's put in the parts that we remember. Interest rate was what, 7.5? We know we're going to make a payment of $200 every month. That's out of our pocket. Our payments per year are 12 because they're making them every month. How many years did they say? Does anybody remember that? It's minus $200
It's
because
40.
Thank you. So 40 times 12 is what? Does anybody know what that is?
$480.
It is. And then if you're making payments of $200, we want to know a couple things here. We want to know the future value. How much are we going to have? Alpha solve. So we're going to have about 60,000. 470, let's see,
$604,765.
700 and yeah, we'll go with that. Now let's take 200 times 480. Can anybody do that? Because that's how much you really paid in.
96,000.
Times 480, 96,000. So we're going to take 96,000 and subtract it from the number that you just got, 604. When you do that, you get $508,765. That's how much they made. How much they paid in was 96. Let's take a look and see if that's all right. And then we'll go over how they got it again. So we calculated just like they did, $604,765. But we made payments every month of $12, which means we made $96,000 worth of payments. But look we made a $508,765. If you would do that, you would make money. It's pretty cool. I mean, that's a lot of money. All right, a geometric sequence again. Now, an infinite geometric sequence means numbers that go on and on and on. And believe it or not, you may not believe it, but they can be added up to a number, to a finite number. So, for example, this little yellow box in front of you tells you the rule. If your ratio is less than 1, they can be added up. Notice the last line said, if the ratio is greater than or equal to 1, it does not have a sum. But we are calculating it with a sum. 1 second. So they want us to work this problem out. Find if this thing can be added up. Well, the first thing we want to do is find the ratio. If the ratio is less than 1, it works. So we're going to take negative 316 divided by 3/8 in our calculator. It's the same thing as what you see here. You just flip it, cancel the 3's. You got 8/16, which is negative 1/2. Or if you're not happy with that, if you can't do negative 316 divided by 3/8, you can use your calculator, but you'll get the same answer. Hopefully. Now we're going to plug it into the equation. The first term of it was 3/8. So you have 3/8. You can see right here, the formula is S equals A1 first term over 1 minus R. First term is 3/8 over 1 minus a minus 1/2. That means 1 plus 1/2. That's 3/2. You multiply by the reciprocal. So it all adds up to be 1/4. 3/8 divided by, I may take that in slower motion because I feel like I'm going here not too fast, but not quite the way I should. I just got a feeling right here. So let's do this one. I want you people to see this and feel it like correctly. So here we have the ratio of 3/8 divided by 3/2. Now, if we wanted to get rid of the denominator, we multiply it by its reciprocal, which is 2/3. Why? Because the reciprocal gives you 1 in the denominator. And anything over 1 is whatever it is. But whatever you do the bottom, you got to do the top. Now you can cancel these. So you have 2/8 over 1, which is 2/8. And divide each side by 2, you get 1/4. So all those numbers added up equal 1/4. All you do is take the bottom and multiply by the reciprocal. Goes away. Whatever you do the bottom, you got to do the top. Any questions about that?
No.
Okay, good. Because it's not hard. Just so you know, a repeating decimal, that's like 7/10 plus 7/100 plus 7/1000. That's 0.7777. Why? Because the first, if you break it apart, is 7/10. Next one is 7/100 and so on. And they do the same thing for this one. The first term is 7/10. The ratio is 1/10. If you take 7 over 100 divided by 7/10, you'll get 1/10. Let me show you that. So I'm going to take the second term, which is 7 over 100, and divide it by 7/10. Now, I'm going to use my calculator because about this time of night, most people are wanting to use things where their brain doesn't have to work so hard. Let's go to regular calculator. We said 7 over 100 divided by parentheses 7/10. And boom, you get 0.1. Well, if you don't think that's 1/10, we can hit math, enter, enter, you get 1/10. That's the whole problem there. I know what we'll do is we'll take a 2-minute break after this, even though we've only been in class for 31. This is a tax rebate, and I think you should know how this works because it is pretty interesting. This is like getting a check in the mail from the government. The government knows and believes that if you get a check in the mail, you're going to spend 70% of it. That's on average. Well, some people spend more. Some will spend $1,500 even though they get $1,400 in the mail. Some won't spend any. But on average, people will spend 70%. So if you get a $2,000 check in the mail, 70% is $1,400. Now, of that amount, people will spend another 70% on average. That's $980 and so on. So now you can see you have a geometric series. So the first term is 1,400. The ratio is 0.7 because we said 70%. So you have 1,400 divided by 0.3. And let's see what that gives us. Now, this is an infinite series. That means if you get, if everybody gets $1,400 in the mail and everybody spends 70% of that, 1,400 turns into $4,667. So let's go back. Let's just do the math on it. We see all you got to do is take 1,400 divided by the ratio. In this case, it was 0.3 because it was 70%. They spend 70%, and 1 minus 70% is 0.3, 30%. And you can see they're spending $4,667. So when someone says, you know, if you got 14, how do you get nearly 5,000 out of the deal? That's what happens. Okay, so I'm going to go down and to the bar, my bar, refrigerator that is, and get something to refresh my drink. We are going to move to 8.5, which is the binomial theorem. All these things we're covering tonight are on the test. That's why I'm doing them. The binomial theorem is here in front of you. You might see how to do this. 6 factorial is, this is in fact 6 factorial over 2 factorial, in parentheses 6 minus 2 factorial, or 6c2. Let me just go to the next page so you can look at this while I'm getting this stuff. You should know how to do this and understand it by the time I get back. Perhaps you can put it in your calculator and see. Everybody okay? I'm going to come back. I'm just going to get a quick drink. Everybody good? All right. All right, I'm back. So six over 2 like this is 6 factorial over 2 factorial, 6 minus 2 factorial. And you can see how they get 15. Now the shortcut of this is this. Let's go to our calculator. Turn it on. Let's clear this out. Let's go to math. Let's go over probability. This is a good calculator. We'll do 3. We're going to put the 6 in front. Some of you have to put in your number first. This one's a beautiful little calculator. And then you hit enter and you get 63 is 20. Is that what we had? Let's see what they said. C3. Oh, we did 6C2. We did 3. Let's do 2. Back to the board. Easy enough. Boom. Go to math. Go over to probability. Hit 3. And we put in our. Let's go back to it. And put in our 6 here. And our 2 here. Press the buttons too fast. There we go. And there you get your 15. Does everybody see how to do that? Now that's important for the binomial theorem. You will have 2 problems related to this on the exam. So if you don't quite get it, you have homework. If you look at example 2, it says expand this binomial using your expansion formula, which is in the yellow box above. Now, in explaining this, you have a number of parts to the puzzle. Let's look at the second line and compare it to the problem itself. The problem itself says you have x plus 2 to the 4th. So we're looking at the, can you guys see my wand wave here at all? For this line? Nobody? Anybody? Can you see?
No.
Can you see where it says x plus 2 to the 4th power?
Yes.
Okay, so now look at all those little parenthesis things. First one you have 4, 0, and 4, 1, 4, 2, 4, 3, and 4, 4. All of that is a pattern. Notice it starts out with a 0. So you have 5 parentheses. Notice now the x to the 4th. Notice that you have x inside it. You have it to the 4th. Plus, and it's not there, but you also have 2 to the 0. Now it's not showing like that. Because it's 2 to the 0 is 1, and 1 times that gives you it. So what you have, I'm talking just between the equal sign and the first plus. You have 4 over 0, x to the 4th, and technically you have 2 to the 0. Now look at the next one. You have 4 to the 1, x to the 3, and 2 to the 1, which is 2. Then the next one, you have 4 over 2, x to the 2, and 2 to the 2. Next one's 4 over the x to the 1, and 2 to the 3. And then you have 4 over 4, x to the 0, which is 1, and then 2 to the 4th. That's the pattern you have to have. And that's what you have to think of. And then you get the solution. 4 to the 0 is going to be 1. X to the 4th. 4x cubed to this times 2 gives you 8x cubed. 2 times 6 gives you 24x squared. And then 4 times 4 gives you times 8 also gives you, 4 times 8 gives you 32x. And then you have 16. That's your binomial expanded. Now, there's a clear pattern in example 2. I'm not going to do 3 because it's the same thing. I'm going to do 2 again. So notice you have a binomial x plus 2 to the 4th. So let's just do the parentheses in front of everything. You have 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. Boom. Now let's look at the first thing inside the parentheses, x. You have x to the 4 and 2 to the 0. Then you have the next one, x to the 3, 2 to the 1. Then the next one, x to the 2, 2 to the 2. Then you have x to the 1, 2 to the 3. X to the 0 is 1, so you don't see it, and 2 to the 4. Okay, then you take your calculator, 4C0, which is going to give you 1. That's this line right here, 1 times 4. Then you have 4 to the 1. That's going to give you 4. X times cubed times 2 gives you 8. X cubed. Then you have 4 to the 2. Now 4 over 2 is 4C2. Let's just stop for a second and do that, just to have a little break and to see what we're doing. 4C2. We're going to put in our math. We're going to go to probability. We're going to do the 3, 4, C2, boom, is 6. 4, correction, let's do it this way. Math, over probability. 3, 4, C3, boom, is 4. Let's go back to the book. Yeah, it's not working. I'm locked up for some reason or another. All right, we're back. Good. So that's how they get their numbers. 4C2, 4C3, 4C3, again, 4C3, that's the second last one, gives you 4, but it's times 2 to the 3rd power. 2 to the 3rd power is 8, so you get 32. And the last one is simply 2 to the 4th power, which is 16. So all those breakdowns you can get. Now, the parenthesis number by itself, in the first one is easy. It's 1. The second one, you have 4 over 1, which gives you 4, but it's times 2 that makes it 8. So in this line right here, where it starts out with 1 times, is expanded below it. Now, it's going to ask you to do what we just did. Then it's going to ask you to do this. This is another easy one, if you understand it. Or, correction, not easy. Doable one. It says it wants you to find the 4th term of this expansion. And you simply got to follow the pattern, the rule. The rule says the n. The n in this case is 7. The first term is 3x. You can see it right here. The whole expansion is 3x plus 2y to the 7th. A equals 3x, b is the second term is 2y, n equals 7, and we're looking at the fourth term. And the fourth term is n minus r. So we're going to take, based on what you see in front of you, it says n over r. Well, n tells you it's 7. R is 7 minus 4, which is 3. Because how do we get that? The fourth term. So R is 3. It says right there, R3. I mean, all you got to do is plug in the numbers. A is the first term. A is 3x. It says it to what's power? 7 minus 3, because n is 7. R is 3. Then it says times b. B is 2y. And it says it's to the r power, 3. So that's the entire formula right there plugged in. If we put 7, 3 in our calculator, boom. Let's go to our calculator. 7, 3. You know, we're going to go over to math. We're going to go over to probability. We're going to hit 3. We said we're going to put in 7, boom, 3. Click it out, hit enter. We get 35. Let's go back to the book. So look where's 35. They don't show 35 till at the very end down here, right there. It's 35. You can see 35. Why they don't put it in there? Because they just keep riding it. So we have 7, 3, 3x. That's the first term. 7 minus 3 was 4, and so on. Now, 7 over 3, you know, is 35. 3 to the fourth power is 81. 2 to the third power is 8. X to the fourth power, y cubed. And so the number in front of it was all this expansion stuff. It shows it's 7 times 6 times 5 over 3 times 2 times 1, but we used our calculator and got 35. So we have the number 35 times 81 times 8, which is 22,680 x to the fourth y3. Now I'm going to stop here for a second. I want you to ask me any question you want about this, because I will tell you how we got every one of these numbers. If you're confused on any number, you ask me. Anybody? You guys got every number here? You can figure out every number?
Can you do an example like on the whiteboard?
Let's see here. Let me do this one point by point. I'm working it out. Let's take a look. One second. Okay, let me see if we can do this on the whiteboard. Come on. Whiteboard. There we go. So the original problem is this, open parentheses, 3x plus 2y, and all this is to the 7th power. Now let's identify the parts of the puzzle. The A part of this puzzle is the 3x. The B part is the 2y. The n is the exponent is equal to the 7. And the r is equal to 7 minus the term you're trying to find, which is this case is equal to 3. Remember, you're trying to find the 4th term, so the r equals 7, which is the exponent, minus 4, that's the term, still 3. Now, the first part is this parenthesis thing. And that's the n over r, which is 7, 3. We looked all this up already. We said that was 35. That's times. This is the formula now. The first term, which is a, is 3x. And that's to the 7 minus 3 again, r, which is let me see if I've got that right. Everything right so far. I just don't want to mess up. Let's go back to the book. Doing this kind of from memory. Seven minus 3. 7 minus 3, which is 4. So r was 7, or they give you r is equal to 3. So it's not 4, r is 3. They gave you r is 3, my bad. So let's go back. Simple enough. There was nothing bad about it. They simply said that this was 3. 7 minus 6. That's all they did. Right there, you see r equals 3. Boom. Okay. So 3 to the x power is 7 minus 3 becomes 4. Then this is times your 2y, which is your b. And this is to the 3rd power again. This is to the r. So this line is critical right here. This is based on knowing your a, b, n, and r. The A is the first term, the B is the second term inside it, the exponent is 7, and R was given as 3, which is always 7 minus 4. In this case, it's the term, the exponent minus the one you're trying to find, your expression, which is the fourth term, which would be 3. So 3 to the 4th power is 3 times 3 is 9. Times 3 is 27. Times 3 is 81. X to the 4th. All of this is gained from this. This is times 2 to the 3rd power. That's 8 times y to the 3rd. And all that is from that. 35 times 81. You can put that in your calculator. Can somebody give me that? $35 times 81,
2,835.
then times 8.
Wait, 22,680.
Exactly. And then you have x to the 4th, y cubed. Now let's see if the book shows that. $22,680, x to the 4th, y cubed. So in this particular problem, this is the best one to look at, solution 4. That tells you how to find it. This is what you'll use on the test. We will go over this one more time, but this is what you should know for the class. All right.
Thank you. That was very helpful.
I tried to go slower, and I tried to go back to the book to make sure exactly what I was saying is how they described it. The book gives you a different way to do that 6/2 thing. I like to use the NCR, but I think it's better. Now, let me go back to my crystal ball here. Let me go back to my attendance and just see who's not here. And then I want to talk a little bit just after this. Just give me 2 more minutes after this. Let's see. Nikki, you're still here? Nikki Anderson?
Still here.
Okay. How about Ryan, are you around?
Yes, I'm here.
Lexa, did you make it? Or Marissa Flores? Nope, nope. Gil says no Jordan. Monica Hickson, are you still here? Yep, I got you. How about Amanda? You're here. I see you at the top.
Monica.
Dylan, are you-
Yes.
Yeah, I got you. Thank you. How about Dylan? No Dylan still. Oh, how about Holly? How did you make it in? No Holly. Erica Whitehead still around? Yep. All right. So here's the plan. The plan is I will send you guys a review for this class for the final exam. According to my sheet here, we'll do the review on Monday the 28th. If I don't send that out to you by Friday or Thursday, would anybody be willing here to give me a call?
I can.
Okay, you have that number, Nikki?
Yes, I have it.
Okay.
You want me
so
to call you on Thanksgiving though? Is that okay?
I mean, you just, if you don't have it by Friday sometime, call me Friday morning.
Okay.
Say, Dr. Wick. Now, it's not going to be critical to you guys. All it is going to be a document that you want to print out. We will go over it on Monday. So if you don't get it till Saturday, it's okay. But I want to make sure you get it in case I forget. I got someone in this class that's going to give me a kick in the butt. I mean, going to give me a tickle.
So do we have class on Wednesday?
No, that I sent that message to you. Did you not get it, Sharon? I sent you an email today.
Let me check it really good.
I just got it sent out about 7 o'clock tonight. Okay. Any questions for me from anybody else? So you'll be off on Turkey Day or day before Turkey Day because we covered the material.
Thank you. Have a good night.
All right. Good night, you guys.
Thank you
I'll
so
start.
much. Good night.
Good night. Good night.
Thank you. Good night.
Happy Thanksgiving, you guys.
Happy Thanksgiving to you too.
Good
Thank
night.
To you too.
Oh, very many thanks.
You guys are
Thank
good
you.
group.
Happy Thanksgiving. Have a good night.
Good night, everybody.
Have a very good one.
Thank you, Hunter, again for all you do.
Have a very good one. Bye-bye. Bye-bye, all.
Bye, Sharon. Bye, Sharon. Bye, Rita. Good night.
You have a wonderful night. Thank you for class.
Thank you.